Hello everyone, you are welcome to today's class. So in today's class, we want to look at areas of prisms, and under this we'll be looking at cuboid and triangular prisms. So that is what we're going to do in this video. So in our previous video, we looked at properties of solids. Today we want to look at how to calculate uh, the surface area of cube and a cuboid using formulas. Then as well as we want to look at the lateral surface areas of cube and cuboid. So then we look at the last one, which is surface area of triangular prisms. So that is what we're going to have in this video. So let's start with the first one. So the first one we're going to look at is when we talk about surface areas of solids. What does that mean? So what it means is that surface area of a solid is the total surface or total area of all the faces. As you all know that in let's take a look at uh, square. In a square, so you know you're going to have, this is a square, this is a cube rather. In a cube, you have the which has 6 faces. All right, so which means area of all the faces, so which means we find the area of each face of a cube is a square. So we're going to find area of a square. Now after getting that, we then multiply everything by 6. So that's what refers to as total surface area of solid. So and to find the surface area of a cube or to find the surface area of solid, so what we need to do is to find the areas of each face. We find the areas of what of each face. Then after finding their areas, then we add them together. So that's simple as that. So let's now look at surface area of a cube. So as you can see here, that when you cut a cube, which looks like a box into its net, this is what you're going to have here as its net. So you can see that we have six faces. We have 6 faces, and each of the face is what is a square. So each of the face is a what is a square. So what is the area of a square? You find the area of one square. So when you find which is what L squared, so then how many are there? 6. So that means we are going to add L squared into 6 places. So that will give us what 6 what L squared. So that is that on that one. So then we move to the next one. So let's look at so that means we are saying in essence is that so surface area of a cube or surface area of a cube is going to be 6 times L squared. So that is surface area of a cube is 6 times what? L squared. I hope that is clear. So that is that on that one. Then move to the next one here, and that is, let's look at the example and how to find it. So look at this example now. So in this example, each of the lines, the faces are, we have the length, each side of a cube is are the same. The side of the cube are the same. So that's why you have 3 here, we have 3 here, we have 3 here. So which means area of a cube, area of a square, now will then be what? Length squared, which is equal to what? 3 what squared. That gives us a 9 centimeters squared. But that's not what we are looking for. So we have to find the total surface area of this cube. So how do we do that? So it's very simple. So what we are just going to do is, how many faces do we have in the cube? So which is area, the total surface area of a cube. Now total surface area will then be what? 6 times what? Length squared, which is going to be 6 times what? 9, and that's going to give us what? 54 centimeters squared. How this is clear. So that is how to calculate this. So move to another point there. Another one is, let's look at another example before we move from this place. So we have this example here. So the surface area of a cube is 150 feet squared. What is the length of the cube? So what we are expected to do here is, since the total surface area is given, and the total surface area of a cube is 150, which is given feet uh, feet squared. All right. So what we're going to do, and the formula for total surface area is 6L squared. So 150. So we divide both sides by 6. This will cancel this. So which means we're going to have L squared equals to, so 6 here 1, 6 here, that is 2, remainder 3 in 30, that is 5, that's 25. So which means L equals to square root of what? 25. And then the length will then be what? 5 centimeters. I hope this is very clear. So that is how to calculate the length when you are given the total surface area. So move to, let's now move to lateral surface. Lateral surface of a cube now. Now, lateral surface, when we talk about lateral surface of a cube, we are talking about the total surface excluding the top and the bottom. I repeat again, excluding what? The top and the bottom. So which means we are only looking for the area of the sides, but we are not going to look for the plane area of the top and the bottom. So which means we are not going to find the area of this top here, of this top and the bottom. We are only looking for the area of the remaining 4 sides. So that is going to like the left side, the right side, the front side, the back side. So that is that. So anything beyond that, it will change from lateral. So that is what refers to as lateral surface area of what? Of a cube or of any shape. So you're not going to look at the surface area, the area of the top and the area of the bottom. So that's how we have, you can see we have 4 here. So in this case, so that means surface area of lateral surface area of a cube will then be what? 4L squared. So as against the total surface area, which is 6L what? 6L squared. So let's now look at the example and see how we can solve problem on that. So let's look at this example. The question says calculate the lateral surface area of the cube below. So in this one, so what you notice is that we're going to find, so lateral surface here. So the lateral surface area, as I have said, is 4L what? Squared. So that's going to be 4 into bracket L squared, that is 4 squared, because the length is 4. So that will give us 4 times what? 16. So 4 times 16 will give us 64, yes. So 4 times, that is the answer then was 64 centimeter squared. I hope this is very clear to you. All right, so the next stage is to now look at, we can then move to cuboid now, another surface area, and that is this. So surface area of a cuboid. Now this is a cuboid here at the top here. Now what you notice is that under cuboid, the opposite faces are always equal. So and each of the face is in form of a rectangle. So that's, you can see that we have the top that we have here, the top we have here, and the bottom here. So that is here and this. Then the right here, which is 3, is also equal to 4 here. So this is 3, this is 4. All right. Then front is here, will be 5, and back is also here, which is what? This is 5, this is 6. So what we are going to do is that we are going to label this. and let's see what we're going to have. So on it, we're going to have, so let's have this side is the breadth, this side is the length, and this line here is the height, which is the same thing as this height here. All right, so we want to find the area of this top here. That will be breadth and the length. This is length times breadth. So for this one to be length times breadth, this also be what? Length times what? Breadth. I'll still give you the shortcut. Then for the right and left, this is breadth and h. Breadth and h. So this will also be what? Breadth times what? H. Then the right will also be what? Breadth times what? H. Then the front and back. This is the front, which is h and L. So the back will also be what? Front, that is height or length times height. This is length times height. This is going to be length times height. So also this also be what? Length times what? Height. So in this case, we can come up with if total surface area of a cuboid formula to go. Total surface area of a cuboid to be. So length times breadth is twice. That will be 2 into bracket length times breadth plus 2 into bracket breadth times height. Breadth times height also appear twice plus 2 into bracket then length times what? Height. So that is the total surface area of a what? Of a cuboid. This is not showing here. So let's read this side. So this is plus 2 into length times height. Now this is what you are going to notice. If you are finding it difficult to recall this, so what you should know is that we have length, we have breadth, and we have height. We want to get the total surface area. You are going to pair them in two. So which one you are going to have? LB, then LH. That is one. Are you with me? Then we know we have two L's now. So we must have two breadth and two heights. So that means the last one will be what? BH. So that's our LB, BH, and LH. Then multiply by 2. Simple. So that will give you, that's just the shortcut. So using total surface area of a cuboid is what? 2 into what? Length times breadth plus 2 into length times height plus 2 into what? Breadth times what? Times height. That gives you what? Your total surface area of a what? Of a cuboid. I hope this is clear. So I hope this is very clear. So okay, that is that on that. Then move to, let's now look at the okay, I've explained that. I've explained this. So this is the same thing. I've explained this one. So let's now go to example. So let's look at this example here. So in this example, so what we have here, so to calculate the surface area of the cuboid below, so this is going to be the length, this is the length, and this is the height, and this is the breadth. So the first thing, let's bring out the formula, total surface area. All right, total surface area, which is what? 2 into bracket length times breadth into bracket plus 2 into bracket what? Length times what? Height plus 2 into bracket breadth times height. How this is clear. So having known our length to be 8, our breadth, oh sorry, this is length is, so length is 0.1, breadth is 8 plus 2 into length 0.1 times height 2.5 plus 2 into the breadth, which is 8 times height 2.5. So, so the next is, so let's now multiply this out. So we're going to have 2 times 0.1 times 8. That gives 1.6. This gives 1.6 plus 2 times 0.1 times 2.5 times, oops, sorry, 2 times 0.1 times 2.5. So this gives us 0.5 plus 2 times 8 times 2.5. So this gives 40. So we add everything together. 40 plus 1.6 plus 0.5. That gives 42.1 centimeters, meters, sorry, is meters squared. So that is the answer to this one. I hope this is very clear. Let's clean this to make it clearer. So meters squared. So that is that on cuboid. So move to, let's look at another example under cuboid. So in a cuboid, so the total surface area of a cuboid is 100 centimeters squared. All right. So calculate its length if its width and height are 1 centimeters and 2 centimeters respectively. Now to solve this is very straightforward. So the first thing to do is the total surface area. Let's write it out. Let's divide this into 2. The total surface area, which is of 2 into length LB plus 2 into LH plus 2 into BH. Mind you, you've been given the total surface area to be 100. So this is going to be 100, then 2. The length is what you are looking for. Calculate the length and the width and height. So this is the width, this is height. So the width, which is breadth times 1 plus 2 into length is what you are looking for, height times 2 plus 2 into width, which is 1 times height 2. So let's say we're going to have. So this is going to give us 2L plus 4L plus 4. That's 100. All right. So this will give us 2L plus 4L. That gives us 6L plus 4 equals to 100. But what we are looking for is not, that's going to be 100 minus 4 equal to 6L. So that is 96 equal to 6 what? 6L. So it is L that we're looking for, the length. Divided by 6 by 6. 6 cancels 6. So length equals to 6L1. 6L1 remains 3 and 36, that is 6. So the length is equal to what? 16. I hope this is very clear. Alright, so for you to now confirm, let's confirm. Let's confirm our answer. How are you going to confirm this answer now? It's very easy. So what we are going to do is we're going to put the formula into it and see what we're going to get. All right. So that's going to mean that we're going to have this. Let me see if this is going to show. Okay. Let's check it. So that's going to be 2 length, which is 16. So 16 times breadth, which is 1. So this will be 16 plus 2 into length, which is 16, then the height, which is 2, that is 32, plus 2 into breadth times height. What's the breadth? 1, that is going to be 2. So let's add this on everything together. This is going to be 32 plus this is going to be 64. This is going to be 4 plus 4. So let's add 32 plus this 96. 96 plus 4, that is what? 100. So this is correct. That's 16 centimeters. I hope this is very clear. Okay, good. So that is that on this one. Then move to the next one. The next one, which is a lateral surface under cuboid. Lateral surface. So the question asks you to find the lateral surface of area of a cuboid. Lateral surface area of a cuboid. So the same way I've explained the other one. The same way, we are only looking at the size, so we're not going to add the bottom and the top together. So in that case, so which means this is what's going to happen now. So this is the length. So this is going to be length. We are only looking at, look at this, h, this side and this side, which is what? This one is BH. So that is 2BH, lateral surface area. We then the 2 into BH plus, then we have looked at the other side, which is this one, which is LH, 2LH, 2LH. So which means that we are not going to have length and breadth, just like this one. So we're not going to have this, the first one. The only one that will be out is this, is the first one. So which is bottom and the top. The bottom and the top will be out. The bottom and others will be there. So that is how you're going to do this. So I hope this is clear. So let's look at an example. So to get this now, this is it now. So we have the calculate the lateral surface area of this cuboid. So what we're going to do is, so the top and bottom, which is LW, which is LH, LW, the same thing as LH. LW is LB rather. So it's LB that will not be there. LB. So in this case, so this is L, this is L, this is B, which is the same thing as W. That one will be out. So we're going to have, so let's write that out. This is height. So we're going to have lateral surface area, which is going to be 2LH plus 2BH. So there won't be LB there. LB will not be there. So that's going to be 2 into length, which is 8, times 5 the height, plus 2 into B, which is what? 6. 6 times I, which is 5. So this is going to give us 2 times 40 plus 2 times what? 30. So this gives us 80 plus 60, and that gives us 140 centimeters squared. I hope this is clear. All right, so move to the next one. So the next one, we're now going to look at another example under that. So a cuboid has a lateral surface area of 360 centimeters squared. Its length is 12 centimeters and width is 5 centimeters. What is the height of the cuboid? So we go to your formula again for you to solve this as well. So lateral surface area, so which is 2 into LH plus 2 into BH. So don't forget, the only one that will be out is length times what? Breadth. Are you with me? Don't forget. So now we have been given the lateral surface to be 360 degrees, centimeters squared. Then 2 into length is 12. That is 12. The height is what we are looking for. All right. Plus 2 into the breadth is 5 times the height is what we are looking for. So we can then find this. This is 360. So this will give us 24h plus 10h. That is 2 times 12 times 8, 24. 2 times 5 times 8, 24. So in this case, so we add these two together. This will be 360. So let's add this. This is going to give us 34, 34h. Yeah. Okay, 34h. So don't forget, what we are looking for is the height. So what are we going to do now? So we divide both sides by 34 by what? 34. So this will give us, this cancel this. So 360 divided by 34. So that gives us height 10.588. So height then be what? 10.588. So which means approximately 10.6 what? Centimeters. 10.6 centimeters. That's approximately 10.6 centimeters. I hope this is clear now. So that is that on cuboid. So let's now look at the final one, which is prism, triangular prism. So this is triangular prism. So when it comes to triangular prism, this is what we have under it. So you can see, why is it triangular prism? As you all know, the definition of prism is that a prism is a solid shape that has the same shape as the bottom and the top. So, and the shape of the bottom and the top here is in form of a triangle, the same triangle. So that is the top. This is going to be top. This is going to be bottom. Is that clear? So in this case, how do we find the area of the prism? When you open the prism into pieces, this is what you're going to have. We're going to have two triangles and three what? Three rectangles. Two triangular faces and three rectangular faces. Now this is the length, which is this one. This is length. This is also this one. Then the breadth here is the base of the triangle, as you can see. So this is the breadth. This is the breadth, right? And then the height of the triangle is here. All right. So for us to now calculate the area, total surface area of this prism, we are going to have two total surface area now. Will be 2 area of triangle, that is half base times height, plus 3, because they are the same size. You understand? So this is this one, the one at the bottom, this one at the bottom, length times breadth. Then for this one will be the side here, length times breadth again. This one also be what? The length times of breadth. It depends. So 3 length times what? Breadth. It now depends if they are different size or not. Let's look at the example and see how it's going to look like. So let's get an example and see it. Now, example, we have this example now. We have this example. So calculate the surface area of this shape below. So this is a triangular prism. So the triangle here is this. This is a triangle. So, and there are two. Then we have this. This is a rectangle, which is going to give us, it's going to be 5 by 8. And the other triangle is what? Going to be what? Rectangle rather. The first rectangle is 5 by 8. The second rectangle is going to be 3 by 8. And the third triangle is going to be what? 8 by 4. But this is 8 here, and this is 4 here. I hope I'm making sense. So that is how it will look at. Let's now see how we can solve this one. So to solve this one, now we're going to have total surface area. So which is going to give us, coming. So let me pause it like I have enough space. So, so this is going to give us area of triangle, that is 2 times half times the base. The base of the triangle here is 3. That is times 3. Times the height, which is 4. So that's the first one. So let's do it this way. So area of triangle. So area of triangles. So that's going to be 2 times half times base times height. So that's 2, these 2 times 1 over 2. The base is 3 and the height is 4. So 2 cancel to 3 times 4. That is 12 centimeters squared. So that is for the triangle. So the second one is going to be area of rectangles. So we have 3 rectangles. The first one is 8 by 3. So that is going to be 3 by 8 plus the second one is going to be this. Let me pick another. So let me pick this. So the second one is this. The one in green. So that is 8 by what? 5. So that is 8 times 5. Then the last one is going to be the one at the back. Look at where I'm going to get it now. Let me clean this. Look at where I'm going to get it. So the last one is going to be this. The one in blue. Can you see? So since this one is 8, this is also 8. And by 4. That is going to be what? 8 by what? By 4. I hope this is clear. 8 by 4. I'm coming. 8 by 4. Okay, 8 by 4. So 8 by 4. So let's now get the final answer. 3 times 8 is 24. Sorry. Plus 8 times 5. That is 40. Then plus 8 times 4. That is 32. So let's add everything together. This is 72. 92. That's 96 centimeters squared. I hope this is very clear. So that is that on this. All right. I'm coming. Okay. All right. So that is that on this one. So the next one is for us to look. I think that is that on this. So that is that on this. So I think that's where we're going to stop here for today. So that is where we're going to stop today. And I hope you find this video useful and helpful. So in our next video, we're going to look at volume of solids. So where we look at volumes of 3D shape, other 3D shapes. So we're going to meet in our next video. Bye for now. Thanks.